Alright, in this video I will be doing the Chapter 7 test from the book to show you guys how to work out some of these problems. Starting with number 1. We have R3 T negative 7 over T5. Oh, it's a T. Simplify, okay. So the R3 has nothing to go with it, so that's just going to stay where it's at. And then the T's, we're going to use the division thing, so it's going to be t to the negative 7 minus 5, which is t to the negative 12. So looks like that, but to simplify it, we move it to the bottom and change it to a 12. So R3 over T12. Sounds like a Star Wars character. Okay, now we have A3 over 5m. So A3 over 5m in parentheses to the negative fourth power. Okay, so the negative fourth power is going to affect both the top and bottom, and both of the things on the bottom. So for the top, it's going to be a to the third to the negative 4 power. I guess we can just put it on the bottom. So then it's going to be 5 to the negative fourth and times m to the negative 4. Okay, so on top, 3 times negative 4 is negative 12, so we end up with a negative 12. On the bottom, we have 5 to the negative fourth power. So, well, 5 to the, okay, so that's going to be big. So 25, 120, like 625 or something. So that's actually, it's actually 1/5 to the fourth power, but we'll deal with the negative portion of that later. And then m to the negative 4. So the negatives actually switch the places. So the a is going to drop to the bottom. So the 625 is going to come up top, as is the m to the fourth, and the a12 is going to drop to the bottom, and that will be the final answer. The reason for that is when you have a negative power, it turns it into the inverse. So a becomes, so a to the negative 12 becomes 1 over a to the 12. And then the 625 to the negative 1, it was already looking like this, right? Because it was already on the bottom. And so when you apply the negative power, it ends up looking like this, which we all know is 1 divided by this, and the division of a fraction actually flips it up to the top. So that's why this, anything with a negative exponent on the bottom of a fraction actually will flip up to the top, because the definition of division by fractions, right? So that's why both of these are now up top and this is now on the bottom. Okay, moving on to number 3. We have C3V9, C3V9, C negative 1, C0. And same instructions. So C3 times C negative 1 is C to the 3 minus 1, and then plus 0, I guess, times V9. So it's just going to be C2V9. The C0 is really a 1, so it doesn't affect anything. Number 4, 2y to the 3/4 h squared times 2y to the 1/3 h negative 4 to the 6th. All right. This looks kind of interesting, but I think it's not going to be as hard as it looks here. essentially this 6 is going to affect the 2, the y to the 1/3, and the h to the -4. So let's deal with that first. So 2 to the 6th power is 2, 4, 8, 16, 32, 64. So I'm just going to write the first part the same as it was. And that this 2 is going to become, and everything's multiplied together. So 64. Y to the 1/3 times 6, well, remember that 1/3 to the 6th power really means y to the 1/3 times 6. So all that's going to do is just become y squared. And then this h to the -4 to the 6th is going to become h to the -24. Put all that together. And let's see, we're simplifying, so it doesn't say anything about radical form. So we're going to end up with 2 times 64, which is 128. Then we have y to the 3/4 times y squared, and so that's going to be like this, plus 2. So let's make it 8 over 4, right? So that's going to be 11/4. So y to the 11/4. So that takes care of the 2, that, and that. Now we have h squared times h to the -24. So 2 minus 24. And so we end up with h to the -22nd, which just means it's going on the bottom as h to the 22nd. And that is it. So let's move on to number 5. Number 5 is 1.2 to the 5th times 1.2 to the -2. Okay, so these have the same base, so it's actually going to be 1.2 to the 5 minus 2, which is 1.2 to the 3rd, which is some annoying decimal. It's going to be 1.44 times 1.2, so whatever that is. Let's see, 12, 144, so 8, 8, 2, 0, 4, 4, 1, 12, 6, 7, 1. So 1.782 looks like. All right. Oops, 1.728. Here we go. All right, number 6. We have 27q to the 1/2 to the 1/3. So 27q to the 1/2, and all of that to the 1/3. Oh yeah, just to remind you, this 1/2, any exponents only see the thing directly next to them. So this 1/2 doesn't see the 27. The 1/3 sees parentheses, so it's going to affect the q and the 27. So 27 to the 1/3 power means the cube root of 27. Cube roots and 4th roots and 5th roots are usually pretty easy if it's going to be a whole number answer, because they get so big so fast that there's only a few choices. So like 2 times 2 times 2, that's too small. 3 times 3 times 3 is 27. So you know the cube root of 27 is going to be 3. Now q to the 1/2 to the 1/3, that's just multiplication. So 1/2 times 1/3 is 1/6. And so that's the answer. So that one's pretty quick. Let's move on. Number 7. Write the expression 4x to the 1/2 in radical form. 4x to the 1/2. Okay, well 1/2 means square root, so the square root of 4 is 2. And then we need the square root of x, so that's it. That was a quick and easy one. 2 root x. Let's go on to number 8. 5th power of a to the 4th as a power with a rational exponent. Okay, so 5th power of a to the 4th. Well, a to the 4th is easy. That's just a to the 4th power, and the 5th root means divided by 5. So a to the 4/5 power. Number 9. Recursive definite. Okay, we're not doing geometric, so we're also going to skip 9 and 10. So 9 and 10 are done. So we'll go to 11. Simplify each expression in scientific notation. So we have 6 times 10 to the 4th times 4.8 times 10 squared. Okay, so first we're going to multiply 6 times 4.8, which is, not sure, 48, 28, so it looks like 28.8. And then 10 to the 4th times 10 squared. Oh, I use a dot here and an x here. That's strange. I'm not going to fix it, but just beware. They mean the same thing. 10 to the 4th times 10 squared is 10 to the 6th. So times 10 to the 6th. Now, this would be the correct mathematical answer, but it's not in scientific notation. So in order to move this decimal back to 2.88, we have to change it to 2.88 times 10 to the 7th, because if you're going to make this number smaller to compensate, you're going to make this number larger. So it's 2.88 to this times 10 to the 7th. Moving on, number 12. We've got 1.5 times 10 to the 7th over 5 times 10 to the negative 2. All right. 1.5 divided by 5. Well, that's like 15 divided by 5, but with a decimal, so it's 0.3 times 7 minus negative 2, so 7 plus 2. And then we have to move this, make it bigger, so we got to make that smaller. 3 times 10 to the 8th be the final answer. Number 13. The human body normally produces about 2 times 10 to the 6th red blood cells per second. 2 times 10 to the 6th red blood cells per second. To express how many red blood cells your body produces in one day. Okay, so we need to multiply that by, so how many seconds in a day? Well, 2 times 10 to the 6th over 1 times, so that's red blood cells per second. So to turn seconds into, oops, that's my alarm, to turn seconds into minutes, we got that, and to turn minutes into hours, we've got that, and to turn hours into days, we do that. So it's basically this number times all those. So let's see. I guess we could just do 2 times all that. So 2 times 60 is 120. 120 times 60 is, what is that, 7,200? So 120 times 60 is 7,200. And then that times 24, I'm using a calculator for the last one, is 172,800 times 10 to the 6th. Now we have to change that to scientific notation. So we're going to have to move that decimal back 1, 2, 3, 4, 5 spots. So it's going to be 1.728 times 10 to the 11th is the answer to part A.